Now to jump into the IoT Upgradable Lighting Challenge. And like I said, at any time, if you do have a question, please feel free to post it in the chat window, and I'll try to address it when I see it. Quickly overview today is I'm going to just explain the concept of a challenge. Also, we're going to discuss kind of the IoT Lighting Challenge performance targets, and we are most definitely trying to solicit some feedback and support. We're here really to listen to you and see what you might want and or where else that we can make changes. So I do see a couple more people connecting. I did mention that if you put anything in the chat window, feel free to do it. I think your phone lines are unmuted. I do have the ability to mute them. So if you also want to pause and ask a question at any time, I can do that as well. Without further ado, I will get into more of the specifics of it. So the IoT challenge and why hopefully you're here is that the dilemma that we have today is that most lighting that is being installed lacks the ability to upgrade it in the future. So traditionally, how it works now is you have to really think through all the things that you want to do with that light fixture and install before you install it, because while it can be replaced later, it's cost prohibitive and it's really hard to make a modification. And that modification or that upgrade that you might want to do is to take a standard fixture, as shown in that photo, and maybe put in a sensor or a lighting control. And you might want to do something in the IoT. I've said IoT about 7 times, so I'll pause and explain what IoT means. We'll talk about IoT more in depth in a second, but IoT means the Internet of Things, and that's using data for secondary options, such as taking data about the space and applying it to the mechanical system or operational. We'll talk about more in depth. Light sensor ports and communication ports are not standardized. That's the other big dilemma. So right now, every manufacturer makes a slightly different sensor size. And if you wanted to have a competitive specification for your project, you're going to be doing a lot of work during the design phase. If you wanted to try to use one manufacturer, and then for some reason that manufacturer, that control manufacturer was replaced in the project for cost reasons or other reasons, you may have to now make sure that light fixture can support that sensor manufacturer physically and electrically and data-wise. As a result, that makes some projects hard. It definitely limits the ability to use lighting controls on projects. So the issue here is, and which we're trying to address with the challenge, one, it's hard to upgrade light fixtures after they've been installed. And two, part of that upgrade challenge is that there's a lack of standardization in the communication, both at the inside the fixture, and then a lack of inner standardization of how that sensor actually fits in the light fixture. So that's where the opportunity is. The idea is bringing together end users who demonstrate a demand to manufacturers who ideally create a product that addresses it. We do define the upgradable technology requirements, and then ultimately we're going to challenge industry to develop a solution that meets this. And then the manufacturers benefit from this because they are recognized as they met the challenge, and Department of Energy supports that and then tries to recognize them through case studies and other means. So it is ultimately pretty beneficial on both sides, where the end users get a newer product that's addressing their needs, and hopefully the manufacturers are recognized, which leads to better value to them because of their efforts. I've mentioned the term challenge. This is not a new thing. It is important to understand that challenges are voluntary, meaning that they're not required, they're not a regulation of any type. As well as there is no direct incentive to manufacturers. So the idea is that hopefully end users demonstrate manufacturer support for the challenge, and that's why manufacturers would ultimately join it, because they see, oh, there's a large number and hopefully a growing list of end users that actually want this product. Therefore, manufacturers feel comfortable leveraging resources to make said product. There are two pretty famous examples, at least from the Department of Energy in the challenge world. One in that first row is the wireless submeter. The idea was that they wanted a meter that could be installed, again, after installation, that would provide some submetering and share information. It had a price component. It said, hey, we know you can do it, but right now that cost is too exorbitant. So this is a good example of something the Department of Energy has done and helped get into the marketplace. And they actually focused on the technology was pretty available, but not at a cost-effective means to do it. And so the challenge really tried to say, manufacturers, there's a way you can make this product cheaper so we can get it installed. So that's an example of something that's happened before. The other is rooftop units. These are rooftop air conditioners, and the idea there was that end users were seeking more efficient air conditioners. They had a number of specification elements here to these air conditioners, and a number of manufacturers met this, and buildings installed them, and they had more efficient air conditioners as a result. So this is, again, two examples where there's an actual challenge. One, it could have been from a price point, maybe not as technical. The other one was maybe more technical. And by grouping end users together and demonstrating demand, they were able to get manufacturers to produce a product. So that's the idea of a challenge. That's how the approach works. The next slide here is just kind of shows the benefits. So in this case, this is a case study that was about two sites. Or the site and the manufacturer. This site happens to be a grocery store, Publix. It's a pretty big grocery store chain in the Southeast. And then they were recognized, and the manufacturer who made the product was also kind of celebrated. So the benefit here is that both the participant as well as the manufacturer are being recognized, and they get some good positive press of what they're doing, and that's beneficial to both the site as well as the manufacturer. So overall, again, that's the challenge approach. Again, I mentioned why the challenge. I mentioned earlier the dilemma that light fixtures can't be upgraded, as well as a lack of standardization. We know that light controls save energy. We also know that there's sadly a low penetration of light controls. That low penetration is partially related to cost, and some of that's perceived cost, and some of that is just change. And a way to address that is by focusing on where we can hopefully address some of those cost issues, both at the manufacturer level as well as the installation issue. And that's what this challenge does. It really tries to move it to standardization to help reduce some of those costs. Lighting can support IoT applications. So the image over there on the right is a space utilization graphic. The idea here is that because there's a light fixture about every 40 square feet, and each light fixture has a sensor in it, they're able to, an occupancy sensor, they're able to use that occupancy data and run it through a filter and do some analytics on it, and they can determine really how dense certain spaces are used compared to others. So in the image to the right, the darker colors reflect spaces that see a lot of human activity as detected by the occupancy sensors that cycle or sample on a pretty frequent schedule. The green or purple area is less busy areas. And this is one example, and we'll talk more about other IoT applications in a second. The advantage of why you would use lighting for IoT benefits, or for IoT, is many reasons. One, light fixtures are everywhere. They're one of the most common building elements. Two, light fixtures have a power supply, whereas your mechanical grill or your doorknob, which are both ubiquitous, they don't have power. So that makes them harder to host a light sensor, or a sensor of any type. It doesn't have to be a light sensor, but any type of sensor. The other advantages are that the light fixture is physically big enough to easily hold that sensor. So you now aren't having to deploy sensors in places. You can do it all through the same body and the same fixture, and you're using that double benefit, as well as not making the ceiling super ugly. And then finally, the light fixtures tend to be in the ceiling or high above if they're suspended. And that's beneficial as well. The reason is that gives you much better line of sight. I have seen examples of sensors that are battery powered that are at people's desks, and they have some advantages. They're cheaper and somewhat easier to use. However, they're battery powered, so you have to constantly update their batteries or replace their batteries. They definitely have some line of sight issues. So you can achieve IoT applications in different ways. Lighting, it makes a lot of sense because there's power and a platform to mount the sensor and other features. IoT can help you has financial benefits to it. The idea here is that if you had a space utilization or some of the other applications we'll talk about in a second, you're able to use that information to make operational changes. It might be changing a lease or real-time tracking of assets. There's many things that can add value in the IoT world, and so that makes the whole system more financially attractive. And then finally, upgradable fixtures can lead to greater energy savings, and they can yield positive benefits for end users. Again, basically, once you put a sensor in there, that light fixture, it can become more efficient itself from a lighting unit, and that can lead to energy savings as well. So that's kind of why the challenge exists, why lighting makes sense for an IoT application, and how the challenge works. I am keeping an eye on the chat window, so at any time, I am going to pause and definitely reach directly out to some of you on the phone call. But I just want to always offer up, if you have a question or a comment, always feel free to post something in the chat. But as we get onto the later presentation, it will be to listening, and I will, if you don't speak up, I'm very comfortable going down the list and directly asking for opinions. So just want to kind of put that out there. These are just a handful of examples of IoT applications. There are many. Really, the idea here is that, for instance, if you were doing people counting, now you can improve your building operations by more precise mechanical control. I'm working on an adjacent but different project, and there we found that just through the use of lighting controls, connecting to the mechanical system, they're saving about 40 to 50% more on their mechanical side by not cooling or providing a fan to spaces that are empty. So that's kind of the easiest and most understandable form of IoT is that can talk to your mechanical system. However, there's many non-energy aspects that you can do with it, such as wayfinding, where you might be looking for an open conference room or possible tracking people's traffic shopping patterns. You can do emergency assistance with it. You can do real-time location, such as tracking objects. Airports are a great example with wheelchairs or stack badging. And I mentioned earlier the space utilization example with the graph there. Or you can ultimately get into, we all talk about healthy buildings now, and the circadian and the color tuning can play a role there that you can do with a digital system and through IoT. And these are just a handful of the benefits and applications that you can do with IoT. Just try to provide context of, okay, in your mind, you might be thinking, I understand light fixture and I understand sensors, but why would I care about IoT? These are just there's about roughly half of the many different applications that you can do with IoT. And there's more, and each of them some have energy benefits, and they all have different value that can benefit the project and the organization. So that's why you might be doing the IoT application. We did poll at a Department of Energy Better Building Summit, and we did ask some basic questions. And we found that, not surprisingly, the top 3 responses right now were related to space utilization, people counting, and air quality. So these are the answers that people ranked as the most important applications that they're interested in. As I say, it's not surprising in the world of COVID. How close we're getting people together is definitely a data point that people are trying to follow. Same with air quality because of just because of those features. So it's not surprising those 3 came up. Then you had asset tracking, which again is the idea of you can put a tag on a device and be able to find it easier, or wayfinding where you're telling people where to go. And then you can get into some additional communication methods through Wi-Fi and visible light. I'm going to pause for a second before we move into more about the challenge. I would love any feedback from anyone on the phone. And as we go, I will start asking direct questions, but I just want to pause for a second. Does anyone have any thoughts about IoT applications? Any general questions about IoT and say, well, why lighting? Or maybe your facility is considering it. We'd love to hear about what you're doing or what success you've had with this technology. I know you're all kind of anonymous right now, but you won't last that way much longer on the phone. So I'm going to pause for a second and just see if there was any thoughts or feedback on IoT applications and anything we should know. Again, this is a listening session, so we are trying to understand what your organization might be doing related to the IoT world. And like I say, I think you're all unmuted or you're self-muting at the moment. So if you have questions, or feel free to type something, anything in the chat, if there's any questions or comments that you'd like to make. All right, I'm going to move into the performance requirements, and we'll talk about them. But I promise you, by the end of the presentation, I will start calling on some of you, trying to really draw you out into the conversation. As I mentioned, the idea of a challenge is you develop a performance requirements, you make them available, you ask manufacturers, can you make this? And then ideally you say, look, manufacturers, these organizations want this type of product, and manufacturers say, yeah, we can make that. So then we get into the performance requirements. This is a very high level. We'll touch base on this more in a second. It's got to be upgradable. It's got to be easy to buy, install, and use. A D4I certified driver, we'll talk about what that really means a little more in a second. Same with Zaga Book 20, we'll talk about that. DLC Premium, also talk about that. Those are performance of the fixture, and affordable. I think the most important thing to understand about this challenge is it's technologically not a big deal, and why I say that is that there are many of these components that exist. This type of driver is available. It's not as used as much, and we'll talk about why that is. The sensor port is becoming a little more, there's more discussion about how to standardize around that. So again, from a technological point of view, both of those things are real and not easy, but they're on the shelf and people understand them. From performance elements, again, there are high performing fixtures. So these are all technically all possible that either exist in small quantities now or potentially exist. Really, it's kind of building them all together and hopefully not a significant cost, which we'll also talk about in a few slides. But again, the key thing to understand about this challenge is it is close to market. We're just trying to get all the parts together and then get them to market and at a reasonable price adder. So this is a kind of a good high-level slide. This is a good high-level slide about drivers. So this is a, just if you're not familiar with the term driver, this is the device that operates the LEDs itself. And when we move to LEDs, everyone thinks, hey, they're super efficient, but I always try to explain that current drivers, what we refer to as 0 to 10, are kind of your flip phone. Yes, it's a small step away from the phones that some of us knew 15 years ago. However, it is still a limitation. So a 0 to 10 driver is considered, and I notice I put that in italics, that it's inexpensive and easy. And the reason why it's inexpensive and easy is, well, it's kind of abundant. There's a lot of products out there. However, it has many limitations to it. And so while its first cost might be inexpensive, its long-term cost can be greater. You should know that 0 to 10 is just a communication protocol, and it's one-way communication. And it's analog, which means it's very limited information. So a way to think about this is that you have from 0 or 1, it's a little confusing, to 10 volts, and whatever the voltage is, it sends that signal. The driver can only do one function when it receives that signal. That's it. There's nothing else that you can do with it. So A, it's limited in the type of communication you can send it with it, and B, if you wanted to get into a half step, let's say, it's very hard to do. So as a result, it works on a basic level, much like your flip phone, but you can't really do much with it, and it's got a lot of limitations. Whereas digital drivers are currently a small portion of the market, but they are gaining some traction. And that I would say that digital drivers are considered more expensive. Now, there's a typo that I'll adjust later, but I meant to say digital drivers are considered more expensive. And again, I use the word considered. At first cost, they can be $1 or $2 more. However, you're getting a lot more benefits out of them, and they have more features. So you are getting more out of it. So it is not a direct cost comparison. They're digital, so again, it's communication protocol, and it's two-way, and that's very important. And that's really where, as an industry, we need to move, because buildings are smarter. You're going to need a digital driver. Also, and we'll talk about what you're going to get out of this in a second, what you get out of a digital driver is that it can start sending more information. It's two ways. So you can actually have the driver tell you how many hours it's operated. It can give you some energy use information. It can say, here's how much energy I, as a device, have been using. If you are using color for any reasons, when you start moving into really dynamic color light fixtures, you really need to be able to send multiple communication signals to vary that color, and you can't really do that easily with 0 to 10. So when you start moving into more complex lighting, such as some of these color changing systems, and when I say color changing, I'm not talking your red, green, blue, which you would need more complex for that as well. Your office might be considering what we call color tunable, which means that in the morning it's maybe cooler, and in the afternoon the lighting changes appearance for warmer. This is a kind of a one way that you could potentially meet your well characteristics, or you may have a hospitality suite. So if you're doing that, you're using a digital drive. You'll need a digital driver, and that's some of the benefits of this. So the easier thing to take away from this is that the digital driver is your smartphone. It's doing a lot more than just being a phone, and you're getting a lot more value out of that. So while I think we understand the cheapness of and inexpensiveness of a flip phone or 0 to 10 driver, you're getting much more benefits out of that. And the industry is going to move this way. It's just going to take more time, and that's one of the things the challenge is trying to address, of how can we get people to adopt digital drivers a little faster. And some of that just comes from these type of meetings as well as the challenge. So I mentioned this, this is really kind of it. I said it has to be D4I certified. This kind of image just shows what that means. D4I is just a collection of these standards, and it really focuses on communication within the luminaire. And what that is doing is it's saying, here, we're going to set up protocols for how you capture luminaire data and energy data and diagnostics data. And I mentioned it earlier, but I'm really going to stress it again. I mentioned it earlier that this can send you now information. The light fixture now can think about it like your car. You get your warning signal saying there's something wrong, or your change oil light saying it's time to change your oil. This is where this type of driver is able to get to. It can get through the diagnostics data. It can give you information about, hey, as a light fixture, I've been operating this many hours. And while we talk about LED equipment lasting a long time, that's very true, but the driver is actually one of your weaker points, much like certain elements of in a car engine, that while the car itself will last a long time, if you don't do regular maintenance or there's failure points, you can have larger problems. And the driver is a great example of that. And so by having actual diagnostic data, it could send it out and saying, its heat it's too hot, or it's been operating this many hours, and you might say, oh, well, at 30,000 hours, let's start building into our capital planning projects that we're going to replace these drivers. You don't have to replace the whole fixture, but you might replace the driver. So that's some of the things that you can do with this diagnostic data, and that's what this certification does. So what it's doing is saying, look, we need to move to digital drivers. We're going to standardize on how we capture this information, and we're going to make it a standard way that we can share that information. Because that's one of the benefits of a standardized process, is that people can then build platforms and understand how to interpret that data and do something with it. Whereas if one manufacturer does it one way and another manufacturer does it another way, that slows the uptick of the technology. So that is one thing that this is trying to do, is standardize on the communication protocols inside the light fixture, and how you store the data and how you represent the data. It also has a power supply that can control the sensor and a couple other features. Here's a kind of a simple way and why, as an owner, you might care about this. Again, as I said, it can provide you performance monitoring. So it can actually tell you maybe how much energy your actual light fixtures are doing. That might be important if you have a zero energy building and need a dashboard, or you're trying to do a custom program with the utility. So there's benefits to having, now this isn't calculated, this is an actual chip that's capturing how much energy it's using. I've mentioned a bunch of times it can do predictive maintenance. That's a real big thing that the industry kind of wants to keep moving forward to. We've talked about how great LEDs will last, but that predictive maintenance is really important, so we can keep making sure that light fixture that you spent money on is going to operate. And then ultimately in the field, this is going to hopefully make installation and commissioning actually faster. And that's where I always try to say that while certain technologies are considered more expensive, you're getting more benefits out of this because it's digital. You can now ID the fixtures. You can now, it's going to limit your errors. It can also automatically transfer data. So you can actually do more with this because it's a smarter system. So while that first cost is a little more, your overall life cycle cost is going to be less because you're going to save it in some of the commissioning and some of the other features. And the advantage of the way the challenge is modeled, as well as the way the D4I protocol works, is we are focusing on the standardization within the luminaire. And by focusing only there, you are free as a building owner to use any communication protocol to talk to your light fixture. And why that matters is that, well, some buildings might be using a Zigbee protocol, or another may use Bluetooth protocol, and that they've already formed relationships. So basically D4I said, hey, if you're Bluetooth, the parent organization that builds the Bluetooth standard, they have a relationship. And so they say, look, we're sending this lighting information. Bluetooth says, oh, we know how that data works. We can then interpret that in the gateway and handle that information. And so by standardizing at the fixture level, you still have versatility in your building of all these different protocols that you may want to use. And so we're not limiting innovation or how your building operates, but we are trying to move to the first step in standardization, and that happens inside the fixture. The other challenge that we have and that we're addressing is the sensor situation. So the image at the top left is just 6 sensors. And you can see I wrote over there, that's just 6 that I kind of found. There are definitely more sensors out there. There's probably a total of 15 to 20 sensor manufacturers, and each one probably makes 2 at least sensor options. Many make more than 2, but I'm just saying there's 2 at least. So you're looking at anywhere upwards of 30 to 80 different types of sensor sizes and shapes. But to be upgradable or future ready, manufacturers and users need to know where a sensor will fit. And if every manufacturer is making a different shape or size, and some manufacturers even make different shapes and sizes within their own families, how do you make that future upgradable? You're essentially having to change that every time you want to change fixtures. That can also limit your ability in the design phase for your competitiveness of your specification. I like to think of the sensor shape kind of analogy as every time you had a flip phone, every time you changed phones or vendors, you ended up having to get a new connector for your charger. And we all remember how frustrating and inefficient that was. Well, sensors are not far off. There is a lack of standardization as shown by all the different shapes and sizes. And those I showed you mostly rounds, but there are also squares and rectangles that I just didn't capture in this diagram. So that's a limitation for upgradability in the future, as well as making things future ready. Also, electrical shapes and connections. How do you connect to that sensor? So that's another challenge or another issue that we're trying to address, is a somewhat standardization in the sensor interface, both mechanically and electrically. That's done through here. This is what they call the Zaga Book 20. Zaga is an international consortium of manufacturers and other entities. They use the word interface, but you could think of it as a port or a receptacle. And here are 3 examples of their kind of interface and how it works. But again, it's standardizing on some shapes and sizes. Some of those sensors that I showed in the previous slide do meet their Zaga requirements. There will be some that don't, but as an industry and as a building owner, you need to know, hey, if we want to make sure that I could upgrade that sensor in a year from now when there's a better, more efficient sensor, or I can do new features, if you don't know what sensor size you have, or if you don't know that you can replace that in the future, you may be risk adverse of installing it. So this is trying to help reduce some of the risks by standardizing on the way it physically fits in the fixture, as well as electrically and mechanically. So that's some of the examples. Another kind of example of how it works, it's a standardized plug connector, and that connects in the fixture. The advantage of a standardized plug connector is now you don't have failures in the field. Even though it may only be 2 wires, that's 2 chances to get it right, and people can always get it wrong. And while that 2 chances seem small, if they do it on every fixture, it gets old and gets expensive. So by a standardized plug connector, you're reducing your installation risk and just making things faster for you. As I've mentioned a couple of times, the benefit of a standardized sensor module interface is it reduces fixture designs and variations. So manufacturers can also benefit from this. Now they don't have to have a separate tool or separate die process for every potential sensor they might use. Sometimes that can be a cost adder as a building owner, where you might want to use a new sensor manufacturer, but they have a novel shape, and as a result, now the fixture manufacturer wants more money to make that custom part to fit that. It can also allow for future-ready designs. Manufacturers will know what's going to be installed, so they can then say, oh, well, we can meet that form factor, and that can allow for more innovation and make it so that fixture can be installed, or that sensor could be installed in a year from now or 4 years from now, because it's future ready. And again, as I've said a couple of times, it allows for competitive solicitation in contracting. By having a standardized interface, or interfaces, because we do recognize you are going to need a couple shapes and sizes, it allows for competitive solicitation. So the advantage as a building owner and end user, you can write a performance specification much better, and you can have multiple names on that specification because you don't have to worry about whether or not it'll fit in your fixture. The images over there on the right are from a real project I did in Chicago. Why I like to show those was that the contractor estimated, wrongly, but the contractor estimated and was ultimately paid for it, an hour to install the sensor at the bottom into each of those fixtures. Had this been a standardized port, we would have been able to have more leverage on that project and say, no, you're asking for an hour when it's an easy to install type of device. So as an end user, this can also reduce some of the concerns you might have on a project of using controls where by making it a standardized process, contractors can't claim that it'll take longer because it's not standard or they don't know how to do it. So that's an advantage of it. Quick summary of everything I've just mentioned earlier. The challenge is really focusing on standardizing shapes and sizes for your connector, for your sensor, and it's building upon the Zaga Book 20 that's shown over on the left. This makes it easier and hopefully cheaper for you. It standardizes on some information within the luminaire. Most of that's related to the diagnostics as well as energy. It also will help provide power to the sensors. But at no time does this limit your ability to communicate outside the fixture through other protocols that you might be using in your building. So it's really trying to standardize on the key issues and allow for much more flexibility after that. Almost done, 3 slides roughly. And then we'll be definitely asking for hear your thoughts and also try to really pull out some more information. And then the light fixture really gets into some performance requirements. I kind of mentioned these just in passing, mainly because some of this is pretty standardized now. As an industry, we figured out how to get more efficient. And so this focuses on how to just be slightly more efficient there. Does some color aspects and glare. From the manufacturers we've discussed, this has been really the least amount of questions we've received. Again, as an industry, we do know how to do this. These are things you have to ask for, and the challenge does ask for those. Price is something that I've mentioned a couple of times in the beginning, and you probably might be thinking about, well, great, these are a lot of features. How does this get addressed in price? So we did ask at the 2020 DOE Better Building Summit, what would be the value and what would you be possibly willing to pay for a fixture that could be upgraded over time? And we did receive a fair amount of feedback saying that they would be willing to pay a small premium for that. I like this slide because demonstrates end users do recognize the benefit of it and that a potential need to pay a price premium for it. However, we did share this with manufacturers as well, and it also let manufacturers know small is the operable word here. It isn't just any price premium. There is a limit to how much end users would be willing to accept for that. So that's where we kind of added a cost component of the performance requirement. It is meant to be really about 10% or a $20 adder compared to an equivalent fixture. We've done a fair amount of research on this, and we found that this is reasonably doable. Some manufacturers provided us feedback directly on some of the different components, and a 10% adder or $20, because those numbers can go different directions, is probably right around where it needs to be. And so far, some of the manufacturers that we've met with have said not only have they given individual pricing, we've heard limited complaints about this price point. So the idea of the challenge is, again, most of it is technologically possible. However, it needs to be done at a limited price. So getting down to, you've heard about the challenge, you've heard about the industry lighting really quickly and what's going on. And I'm going to here's the stuff we'd like to get definitely more feedback, listen to you about. What's important, what's valuable? Is it the energy savings? Is it the ability to upgrade after installation? Is it the standardization of drivers? Is it maybe the shift to digital drivers? Is it the standardized sensor control interface? Is it the marginal cost increase? Is it future ready for IoT applications? So these are really what we're hoping. We'd love any feedback you have about the challenge. We'd also, if you think this is the greatest thing since sliced bread and would like to also possibly join on as a supporter and tell manufacturers, yes, you'd love it, we'd like to follow up with you separately there. But I'm going to pause, and I'm going to actually directly start asking you, the attendees, to state your name and maybe your organization, and then also just maybe give us a little feedback of what you've heard. Definitely any questions you have. And I do have the list in front of me, so I am just going to, I think I'll just call on some of you, and hopefully you're paying attention. And we'd love your feedback and your thoughts. So John Kramer, if you're available to unmute yourself, if you could explain your organization and any feedback on the challenge, and or what we'd love to really know what's important about it or valuable.
Yeah, can you hear me?
Yes.
I came in a little bit late, but I'm interested in learning everything I can about the drivers. And that's where I picked it up, and I'm going to have to go back and review it when you repost this again, so I can sit down and really spend time watching it instead of having be called to do something with a job here. But it was really interesting on what I saw with the drivers, and I need to follow up on that.
Great. And can you just remind me what organization you're with?
I run a health club in Illinois.
Okay, great. I will definitely follow up separately. We actually have some experience in that area, so I think there's some benefits there, and we'll definitely follow up. And I totally understand getting pulled in from other meetings. So and yeah, the drivers it's kind of a small aspect of lighting that we don't talk about enough. So yeah, great. We'll follow up and share more.
Thanks.
Yeah, thank you. Charlotte Young, could I ask you to unmute and name your organization and questions, thoughts, opinions?
Yeah, definitely. Hi, and thank you so much for this. I am an ESG analyst at Welltower and really wanted to listen in for my own education. Definitely interested in just learning more. Definitely, obviously, it's important to us to consider energy saving, and so thank you so much for this.
Is Welltower considering any other the healthy building aspects, or using any kind of, or looking at IoT for asset tracking like wheelchairs? I think Welltower is a outpatient medical.
Healthcare. Yeah, exactly. We're just right now kind of in the education phase and feeling things out for sure. But definitely could have a conversation in the future.
Okay. And when you say feeling out, is there of the and I apologize, I will talk to some others on the phone. I did just want to zone in here a little more. As a building owner, is the ability to upgrade, or if of these things on the list, is there anything that really stands out of does that help? Is the upgradability something that's really key, or is it maybe just the low cost or energy savings? I'm just trying to dial in a little more.
I think it's a mix of both, to be honest with you. Obviously, on our outpatient medical side, it's easier to do upgrades than on our seniors housing side. So we're definitely interested in that.
Okay. Yeah, I would. We'll definitely follow up. I have a tangential related project where we're using, which I always call the very least IoT system, but I mean, not system, but concept. We're using the sensors to talk to the mechanical system in 2 outpatient facilities. And so when the exam room's not occupied, for instance, we're able to reduce the mechanical fan and temperature. And as a result, in a couple of the projects, we're saving about 30% of the mechanical just by really optimizing it using the sensor. So there's so much more you can do with IoT.
Yeah.
But, that's like the first minimal step. But all I'm trying to say is that that's outpatient. It might be somewhat interesting.
Applicable to us. Yeah,
Yeah.
Thank you.
Yeah, so we can follow up separately. And thank you for the help. So good. So we'll follow up more on there. Andrea, I know that you represent some of the better building sectors. I didn't know if what you heard here might help them, or if you feel there's still questions that I don't know which sector you support directly, but do you have any feedback that would be helpful?
Yeah, sure. Hi, Michael, and also hello to Charlotte. I'm glad you're able to join. Yeah, so Michael, to refresh you, I represent commercial real estate and healthcare. And we've been, letting partners know the last several months about, the challenge and all of that. I think there's definitely, I'm glad you're able to call on Charlotte first to give her perspective from Welltower, especially with our healthcare partners, being able to use that potential, COVID tracking has come up, or, just being mindful of, spaces between people in certain rooms, and, people moving throughout, common areas and buildings would be really interesting. And this is something that we've also been talking to our commercial real estate partners about, as a lot of them have office buildings and are coming back to their offices, over the last couple months and into the future. They're definitely looking at ways to track where people are and the spaces between them. So I'm sure that's obviously something that you guys have considered, but that could be something, maybe a more timely focus on this is, kind of ways to use it in the return to office buildings kind of application.
Yeah, I got an email for a webinar next week on contact tracing, and I know at least 2 people who've quickly rolled out the apps, and that's always one of the things where we're trying to mention with the Focus Ready. If you don't have the fixture and the sensor, the contact, you can't do it, and so they actually had already built they already had the material in the sensor already, so they were able to deploy the app really quickly because it already somewhat existed. So yeah, I can totally understand both commercial real estate and healthcare everyone's talking about that, trying to get back into these buildings. So yeah,
Yeah.
makes sense.
Perfect. And, you know, I'm always available to help, you know, send out this information and get you connected to people. So if you do need more connections with partners and all of that, feel free to reach out. I'll give one quick bit of information. So Allie Georgeson, who I'm sure you might call on in a moment, just started at Retech as well. She's supporting me on healthcare and Siri. So she's here to listen in. So I will save her from the fear of getting called on because she was going to turn it over to me anyway. So.
Okay, super helpful. Thank you for, yes, I was actually working. So then, Andrew, you know, also your sector, are there things that?
Can you hear me?
Yes.
Oh, I think I just lost audio from your end.
Oh, I can hear you. Can other?
Neil, can you hear me? I'm not getting any audio from your end. Can you give me a thumbs up? Okay. All right, well, I will go then. Not sure why I can't hear everybody. I might have to sign back in here. Yeah, so again, representing the contracting team on this, but I think trying to channel some of the CRE stuff that Andrea mentioned and think about our clients on the private sector side, I think the key attributes that I think are very well represented here are standardization and flexibility, right? The standardization of drivers or of like the sensor and control interface, that's going to allow somebody, regardless of who's occupying the space or what type of space it is, to adapt and use this technology effectively. So I think that's critical. And then certainly the ability to upgrade after installation. I think one of the myths out there is that IoT has to be expensive or that you have to install sensors right away. And obviously the answer is that you don't. You can install a fixture that is ready to be upgraded, and that you can choose how to do it when you want to. So I know, Michael, that folks at P&L are very tight with NIA, and I know NIA has been doing a lot of this, what they're calling LLLC, luminaire level lighting control, and the Mythbusters sort of series there. So I think there's some good tie-ins there, and I'd be happy to share that content if you don't already have your hands on it, but I get the feeling you might. So I'll stop there.
Oh, thank you, Andrew. And I don't know if you can hear me or not. So we'll follow up separately on that. We are tight with NIA. I don't actually know, part of the challenge is you don't know all the details everyone's doing. So I think it's helpful to, I'll connect with you and or our contact at NIA about the Mythbusters. That's a good topic and a heading and does relate to it. Yeah, but we do talk to Nia a fair amount. So good. Well, we are approaching the end of the hour, and I do see a few people dropping off, which is totally understandable. Those that, I'll just go to the last slide. I will be following up, or not I, but at least someone from the team will be following up with both the, with you, John, and you, Charlotte, for sure, as we have directly regular contacts with some of the other people on the phone call. So here's just our kind of our schedule, just so you're aware of it. This is also my contact information if you need it. And we do, like I said, we know components of this already exist. We do know that some more drivers are becoming available in the in early 2021. So we expect to actually see products available about this roughly in the early summer of 2021. So we are just in the final phases of finishing our performance requirements. The ones I've shown you are very much what they will be, but we've had to modify them a few times based on some comments. So we're about to finalize those, and then we'll have this big kickoff. So I will be following, like I said, someone from the team will be following up, mainly because we would like to engage a little more. Also, even we have a pretty generic kind of form letter that we would mind if you'd be possibly interested in filling out or signing. The idea is, again, the more people we can demonstrate to manufacturers that there is a real desire for this product, it isn't just something we're asking them to do. If they say, oh, organization Y or company B is interested in this technology, it helps them get an internal approval on the project. So that might be one of the asks you might hear from us, but that's about it. So you might get a couple minutes back, but I just wanted to, thank you for attending and see if there was any other comments or questions that we can explain a little more. Any slides, if you really want to see more about drivers, let me know.